Hey there, in this video let us talk about the basics of composite functions. So first of all, what is composite function? So previously, if you see the diagram here, previously we learned about individual forward function, correct? So if you see here, the g function here connects 1 to become 4. Okay, that is one function. And then the f function here connects 4 to become 5. So that is another function. Now if you combine a few functions, that's what you get. That's when you get composite functions. Okay, so composite function is basically a combination of several functions. Clear? So question is, how do you write? So in this case, if you see, we are going through g function and then going through f function, correct? But if you write the composite function, so you see this line here that I drew. So when you want to connect from the first to the last, so 1 to 5, you have to write as the composite function. But how do you write it? If you write like this, gf as the composite function, it is wrong, because for some weird reason, composite function, we read it from right to left. Okay, so since you're going through g function first and then going through f function, so you should write g on the right and then f on the left. Okay, because you're reading from right to left. So remember that composite function, you're always reading from right to the left. So I give you an example. Let's say gx is equals to x plus 1. Okay, then I ask you, what is g2? Obviously, we learned previously in the basic function video that you're going to substitute 2 into the g function, correct? You're going to substitute 2 because 2 is the object. So you're going to substitute 2 into the g function. So this is the same thing actually. You're reading from right to the left, correct? Because you're substituting 2 into the g function. So you get 2 plus 1, answer is 3. So the same thing applies here. When I write fgx, okay, or let's say fg2, for example, what I'm trying to do is I'm trying to take the 2 here, substitute into the g function, and then the answer I get is going to be substituted into the f function. Okay, or if let's say I write, instead of g2, I write gx. So what does this mean? X you can't substitute into g because the g function already comes with the x. So instead of that, you are basically substituting the whole gx function into the f function. Okay, so just remember this thing. You're always reading from the right to the left. Okay, so although you are going through g function first, then going through f, you don't write gf, you write fg. Okay, because you're reading from the right to the left. Okay, never mind, we'll go through some examples and I'm sure you'll understand. So let's see this first example here. You have got f function, you have got g function, and they ask you to find fg and gf. So I want you to see the difference. So the first one here is fgx. So fgx, remember I told you you're reading from right to left. So that means you want to substitute gx function into the f function. Okay, so what is the gx? So gx is this. You're going to substitute into the fx function. So it's going to be 2. See, I'm going to write the fx function first. So 2x minus 3. But the x here is not x, because why? I'm substituting the gx function, right? So the x here is going to be 3x plus 1. 3x plus 1. So that is what I'm doing here. I'm taking the gx function and I'm substituting into the fx function. Clear? So I hope you understand this. It's just the concept of how you write composite function. Clear? So now you can do like how you normally do. So you get 2 times 3, 6x plus 2 minus 3. So your final answer will be 6x minus 1. Okay, so this is fgx. Now, will it be the same as gfx? Of course, it won't be the same. Okay, because they are two completely different composite function. So in this case, you're going to get gfx. So what you're doing is you're taking the f function, substituting into the g function. Okay, so what is the g function? 3x plus 1. But the x cannot be, you cannot write x, you have to write f function. So the f function is 2x minus 3. Okay, so what do you get? 3 times 2, 6x minus 9 plus 1. So your answer is 6x minus 8. Okay, so this is how you solve basic composite function. Okay, so now let's see the second question here. Now instead of asking you to find, since you already found fg and gf, now they give you the value of the input. Okay, both input are 1, so you just have to substitute into the existing function that you have, because you already have the fg and the gf function, right? So now your input is 1, so you just substitute. So fg will be 6x minus 1, so it's 6 times 1 minus 1. So answer is 5. And gf function, gf1, so 1 will be substituted, so 6 times 1 minus 8, so you get negative 2. Clear? So this is how you solve when they give you the input. Alright, let's see the next one. So this is a different type of question. So sometimes the question, right, they can ask you for f square x. So what is f square x? Now f square x is not the same as squaring it. Okay, it's like some people like to do this. So what is the fx again? So the fx is 2x minus 3, right? Okay, we know that fx is 2x minus 3. Now some people like to do this. They see this f square, right? So they do this 2x minus 3 and they square. Now if you do this, you got it wrong. Okay, you can't do that. Why? Because f square x is not the same as actually squaring it. This means the square here, the square here, what it means is, that means there are 2f. Okay, so if there are 2f, it's like this, f x. Okay, so what is this? Remember I told you you're reading from right to left. So that means you're going to take the fx function here and you're going to substitute into the fx function again. Okay, so that's what it means. Okay, it's not squaring it, it's two different things. Okay, you're substituting it. So in this case, fx is what? 2x minus 3, right? So you're going to substitute 2x minus 3 back into the 2x minus 3 again. So it's going to be like this, 2 and then 2x minus 3 minus 3. Okay, so you're substituting the fx into the fx again. Clear? So what is your answer? You will get 4x minus 6 minus 3. So your final answer is 4x minus 9. Okay, now what about this? Now you got f3. Now this is not f cube. Remember I told you this, the 3 here means you're going to substitute, that means there are 3 of the f. So f3x is the same as fx. So what this means is you're going to substitute fx here into f again and then back into the f again. Okay, so you're going to substitute 2 times. Okay, but since you already have f2 here, we have already calculated f2, you don't have to do so long steps. Okay, you don't have to make it so troublesome. What you can do is you can write like this, f2x. Because why? This one is the same as f3, right? If you combine, you actually get f3. So what it actually means is you're substituting the f square, okay, the f square x, substituting into the f function. Okay, so it looks like this. So the f function is what? 2x minus 3. Okay, but instead of using x, you're going to use the f square. So the f square is 4x minus 9. So your answer is 8x minus 9 times 2, 18 minus 3. So your final answer is 8x minus 21. Clear? So that's how you do this. Let's see the next one. Now the second type of question they can ask is similar to what we have learned previously in the inverse function video, is that they ask you to do comparison. So you see this question here, you got fx, you got gx, okay, and they also give you a composite function fgx, okay, and then they ask you to find h and k. Where's the h and k? H and k is here, h and k. They want you to find the value of h and k. So in this case, what are you going to do? Of course, since you have the composite function here, you can use the two individual function, combine them to become the composite function similar to this, and then you compare. Okay, so that's what you can do. So we'll do that together. So since you have fg, we are going to do fg. So fgx means what? You're going to substitute gx into the f function. So you get, so fx is hx plus k, but the x here, you can't use x, you have to change to, oh wait, I need a bigger space. So it's going to be x plus 1 square, okay, I use a bigger bracket, plus 4, then plus k. Okay, so this is the g function, gx, and then the entire thing here is the fx function. Okay, so I'm substituting g into the f function. Okay, I hope you are following me, because if you don't get it, then it will be difficult as we go forward. So try to understand this first. So let's substitute, let's expand this. So what we can do is we can expand we see this as 1, so you multiply this and then multiply this. So you get hx plus 1 square plus 4h plus k. Now, can we compare with the existing one? So the existing one, which is given to you, is what? 2x plus 1 square plus 4. Okay, that's what is given here. So now, can you compare? So since these are the same, so we know that h is actually equals to 2, and this 4h plus k is equals to 4. Okay, so we can more or less solve it already. So we know h is equals to 2, and we also know that 4h plus k is equals to 4. Okay, so we can substitute h is solved, so 4 times 2 plus k equals to 4. So k is equals to 4 minus, so 4 times 2 is 8, so minus 8. So answer is negative 4. Okay, so that's how you get h and k. Alright, so now let's see another one. This is a similar question. Oops, sorry. It's a similar question, also comparison, but they got one extra step. The extra step is they want you to find g square 3. Okay, so what does that mean? I mean, I'm sure you know what is g square. That's what we did just now. G square means what? There are two g's. Okay, so gg. So gg and then 3. Okay, so first thing is, before we can even do this, we have to find what is g first. Because why? The given g function here has p and q. Okay, so you need to find what is p and q first before you can solve this. So you got two steps you have to do. Clear? So now let's do this together. Since you are given gfx, so we will form a composite function with the gfx composite function. Okay, so you get gfx. So you're going to substitute what? Fx into the g function. So it becomes p and then 1 minus x square plus 9. Okay, so in case you can't see, this one here is the f function, 1 minus x, and px plus q, px square plus q is the g function. Okay, so okay, that's it. So now let's what do we do? Okay, we have to expand, because why? Otherwise we cannot compare with this. So we have to expand this. So when we expand, we get 1 square minus 2x plus x square plus q. Okay, I just expanded this bracket here, and then we expand the p, so you get p minus 2x plus, minus 2px plus px square plus 9 plus q, sorry. So now let's see, we can rearrange this such that it's the same format as this. So it will be the x square is in front, minus 2px plus p plus q. Okay, so now we will compare with the given one. So the given one is gfx equals to 3x square minus 6x plus 5. So what can we see from here? We know that p is equals to 3, correct? Not only that, you can actually check here. So you see here, 2p equals to 6. 2p equals to 6, so you know p is equals to 3, right? Because 2 times 3 will be 6. So from there, you can confirm that p is equals to 3. Second thing you have to find is q. So you can form with this. Okay. So what do we have? P is equals to 3. We already can confirm that. Next thing is, we also know p plus q equals to 5. Okay. So q is equals to 5 minus p. So p is 3. So q is equals to 2. Okay. So that's how you solve for comparison using comparison method. Okay. Let's see the next one. Alright guys, there's one more thing that I was supposed to highlight in the inverse function video, but I've forgotten. So I'm going to highlight it here. Okay, I apologize for that. So this is a very, very important property. Okay, so what's the property? The property is when two functions, when you have a composite function, but both of them are inverse to each other. So for example, let's say f and then f inverse x, or f inverse and then f. Okay, so if you notice, they are inverse to each other, correct? When you see a composite function but both of the function that is combined are inverse to each other, then the answer for that is always x. Okay, it is always x. Why is that? Because you should understand the concept of what remember I drew for you last time, like this. You got two circles here. Let's say one. Okay, let's make it easy lah. You know that it's going to go forward function is like this, and inverse is like this, correct? Now if you go forward and then you go inverse, where do you end up? You end up in the same place where you started, right? So where did you start? You start at the object. So that is why when you go forward and inverse, or even you go inverse and forward, you end up in the same place as where you started, which is the object. That's why the answer is always x, because x is the object where you started, correct? So that is that's the meaning behind it. You have to understand why it becomes x. Okay, so sometimes question can make it complicated for you, but it's actually not complicated. They write like this: f inverse 5. Then ask you, what's the answer? Well, you just get back the input, right? What's the input? What's the object? Object is 5. So f inverse is equals to 5. Clear? Or sometimes they give you like this: f inverse f 10. So what's the answer? Answer is 10 lah. Because you go forward and then you go inverse, or you go inverse and then you go forward, you end up at the same place where you started. So if you started with the object is 10, then your answer is also 10 lah. Clear? So this is what it means. So the main thing you have to understand is, when you have forward function plus the inverse function, you get the object. So that's what this thing means. Okay, so please bear that in mind. Why is this important? Later you'll understand when I go to a different part of composite function. Okay, let's go and see that. So let's see this. So this one here is you need to solve these two questions. Actually not two lah, just one of these. You will need that concept which I just taught you. Okay, so let's see. So now given here, you see this first question here, you are given fgx, okay, so a composite function, and you have one of the function given, and you are required to find another function. So how do you solve? Now there are two types. The first is, if let's say the unknown that you're looking for, okay, if the unknown right here, unknown is on the right hand side, okay, right hand side. If it's on the right, you just do like how you normally do, okay, the basic of composite function. So see, fgx equals to 2x minus 5. Okay, so since the unknown you're looking for is this, the gx, which is on the right hand side, okay, you just use it as an unknown and substitute into the f function. Okay, that's how you normally do, right? Composite function. So just do that. So in this case, what is the f function? f function is x plus 3. So instead of writing x plus 3, you're going to substitute gx, right? So the x here becomes gx. Gx plus 3 equals to 2x minus 5. So bring this over there. So you get gx equals to 2x minus 5 minus 3. So answer is 2x minus 8. Okay, so this is how you solve it. Very easy. So the key thing is, if the unknown you're looking for is on the right hand side, then you do like how you normally do. Clear? Now the harder one is when it's on the left. Okay, when it's on the left, that's when you need the concept, the properties that I taught you just now. Okay, let's see. So you see here, you are given fgx and you're given gx. Okay, now you need to find fx. But where is the fx? You notice the fx is on the left hand side. Okay, it's not on the right hand side. If it's on the right, you can do like how you normally do. But since it's on the left, now you need to do this. So the unknown, I'm going to write here, unknown is on the left. Okay, so if the unknown is on the left, I suggest you use the property that I taught you just now. So that property, this is just my own words. It's not actually a name for it, but I like to call it like this: neutralize. The neutralizing method. Okay, so remember just now I told you when you got f and f inverse, you get back the object, right? So basically what it means is you are neutralizing these two and you get back the same thing, correct? Or if I write like this, f inverse and then f, so you are neutralizing these two because they are opposite, right? So you get back the x. Okay, so the same concept we are going to apply here. How are we going to apply it? You see, you have fgx, correct? You have fgx, but you are looking for what? You're looking for fx, right? So if you want to look for fx, you need to remove the gx. How do you remove? That's why we use neutralizing. We can remove by substituting this value here. Okay, we substitute with g inverse x. Okay, so from x here, it became g inverse x. Why you do that? Because you can neutralize. So when you neutralize, what do you have? You have fx, correct? So that is the concept we are going to do. Okay, we are going to put in the inverse of whatever you want to eliminate. Since I want to eliminate the g function, so I put the inverse of g, so that I can eliminate the g, and I'm left with whatever is on the left here, which is the fx. Okay, so remember, if the unknown is on the right, which is the previous example just now, if it's on the right, you just do like how you normally do. But if the unknown is on the left, like here, then you have to neutralize it, okay, by eliminating the one on the right. Okay, so let's do this together. So I understand the concept, because if you understand the concept, it's very easy already. Okay, never mind, let's do this together. So you have fg, right? Fgx equals to 2x minus 5. So now, like I said, you want to substitute what? You want to substitute the inverse, so that you can neutralize the gx. So you want to find the inverse first. So that's the additional step you have to do. Find the inverse of gx. So since gx is 2 plus x, so I hope you know how to do inverse. If not, you can check out the inverse function video. So I'm going to make this become y first, so that it's easier for me to shift. So now, since y is the subject, I'm going to rearrange this equation such that x become the subject. Okay, so when you rearrange, you get x equals to y minus 2. Okay, so x equals to y minus 2. So the x is what? Now the x becomes inverse. So now instead of y minus 2, I need to write x minus 2. Okay, now like I said, if you don't understand, please refer back, because I don't want to explain so much again. Okay, so this is g inverse x minus 2. So now that you have the inverse function of g, you can substitute into here. Okay, so where is, okay, so we got fgx is here, so we're going to substitute g inverse like this. Okay, so this x here is, okay, let me use a different color. This x here is going to become g inverse. So that means what? You're going to substitute the g inverse into this function. Okay, so you get 2. Now instead of x, it's going to be x minus 2 minus 5. Okay, so here you neutralize it. Okay, so what you have is fx. So this one becomes 2x minus 4 minus 5. So your answer is 2x minus 9. So that is your f function. Clear? So that's about it. I hope you find this useful. I hope I didn't confuse you. So the main thing is, the hardest part is this part only. Okay, I mean, in my opinion. Yeah, so I hope you find this useful. If you're not sure, you find this confusing, just leave a comment and I'll see what I can do to explain. Okay, so that is all from me, and I hope to see you on my next video. Take care. Bye bye.